All right, guys, I just want to go over a few key examples from the homework last night, the practice quiz. Remember, your practice quiz is going to look very similar to what you see today. So pay attention and make sure you're understanding what's going on. First question, square root of 192. Remember, you can break these down in several different ways. So I chose a longer way to show you what you're going to have to do, but this is not the fastest way. If I break this into 16 and 12, 16 times 12 gives me 192. Square root of 16 gives me 4. Remember that when you square root something, you no longer have the square root symbol along with it. Okay. Square root of 16 is 4. Square root of 12 travels down. 4 continues down again because I need to break down 12 into 4 and 3. Square root of 4 is again 2. Okay. These two get multiplied together to give me 8, and the square root of 3 just travels down, so I get 8 square root of 2. What this means is that I could have used the square root of 64 times the square root of 3. Okay. 64 times 3 would also give me 192, and this would also give me the short path to 8 square root of 3. Let's look at number 3. You can see 10 for yourself. Number 3, remember, if we have a radical in the denominator, we have to take that radical over itself and multiply straight across. So I get the square root of 20 on top. Remember, radical times radical gives me a radical. Square root of 20. And then remember, square root of 4 times square root of 4 gives me the square root of 16. What square root of 16 does give me 4 for an answer. So I got root 20 over 4, and I got to simplify this root 20. And so root 20 can be broken down into 4 and 5, and so I end up with the square root of 4 times the square root of 5. Square root of 4 is 2, so I get 2 square root of 5 on top. I say on top because that goes back up here, so I have 2 square root of 5 over 4, and then I simplify this 2 over 4, and I get 1/2, but I don't really have to write that 1. Obviously, this is a perfect square. Kind of going through these fast. If we look at 5 and 6, these are right triangles that you have to use Pythagorean's theorem for. And it says use simplest radical form. It'll say that on your quiz as well. So we end up with the square root of 250 equals x squared. Square rooting both sides. I have to break down the square root of 250. And I notice that 25 goes into 250 because 25 times 10 gives me that. Square root of 25 is 5, so I get 5 root 10. Same deal here. Don't forget that if you're only given 2 values, actually the directions will be very clear. It'll say use Pythagorean's theorem, so you're going to know that you're going to need to do that. But again, anytime you're given 2 sides, you're going to have to find the missing side anyways, and that's what you're doing in these problems. So in this particular problem, you're going to have to subtract the 7 squared from the 225 to get 176. Square root of 76 breaks down to 16 and 11, and that's not the only way to do it, but this is the fastest. Square root of 16 is 4, and you're left with root 11. All right, moving on to the next part. Special right triangles. Remember, the general form is, if this is a 30, 60, 90, we get 60 here, 30 here, and that's our 90-degree angle. Opposite of 30 is x. This is x squared of 3, and that's 2x. And a 45, 45, 90, x, x, x squared of 2. Sorry, my x's aren't coming through. So if you're finding x in this particular problem, you got to take 12 divided by root 3, fix that problem. When you simplify, you have to simplify your 12 over 3 to get 4 root 3. To get from here to here, you got to multiply by 2, so we get 4 root 3 times 2, which is 8 root 3. In question 8, we got to take that one and divide by the square root of 2, which is what I have here. And then, again, fixing the problem of the radical in the denominator, multiplying straight across, we get 8 root 2 over 2, and then simplifying, we get our 4. Moving right along, so this is quick. These ones, you are asked to solve each triangle. Remember, that's finding all the missing stuff. Okay, yours will look exactly like this, but different numbers. Easiest thing to do this one is first subtract from 180 to find the measure of angle x. The measure of angle x is 54 degrees in this case. Then if you're using this angle here to find, let's say we want to find z first, if I'm using that angle, then I have to use the sine function, because sine there is opposite, and this is the hypotenuse. Opposite hypotenuse is sine. So I wrote sine of 36 equals z over 25. Remember, this is what I said you have to show that next step here. to show that the sine of 36 is 0.5878. And then literally just cross multiplying, okay? Z is equal to 14.7, that goes here. And then you can use Pythagorean's theorem to find the missing side of 20.2. This one is a little bit different in that you have to use your inverse trig functions. Probably the easiest thing to do here first, which I didn't do because that wasn't what was asked first, but is to use Pythagorean's theorem to find the third missing side from 21.2. To find the angles, if you do this first, remember you can, if you know that this is 21.2, remember you can use any trig function you want in order to find any of the angles. But if you're not given that, then you have to use tangent in this case because we don't have the hypotenuse. Remember, hypotenuse is sine and cosine. So I set up the tangent of r to find that, and an opposite is 12 or 13.5. Adjacent is 16.3. So I set that up, and this is where we have to take the inverse tangent function. Remember, you got to find the decimal value of this, and then remember the inverse function eats up the decimal, spits out the angle, and if it asks to round to the nearest degree, nearest whole number, we need to round that up to 40. And then subtract to find 50 for the next one. All right, last question here. The Madison Square Garden problem. If you draw this, remember the angle of depression, if this is the line of sight, the angle of depression is how far you have to move your eyes down, okay? Angle of elevation, if this is your line of sight, the angle of elevation is how far you have to move your eyes up. Okay, so if you're looking up at something, it's elevation. Looking down at something, it's depression. Okay, so angle of depression. If we set this up, the building's 35 feet tall, and the Madison Square Garden is 1,350 feet away. Two ways to go about doing this. You could transfer this 35 measurement to the other side, so this is 35, and then you can go ahead and use this triangle here in order to find the angle of depression. What I did is, instead of doing that, is I used this triangle, found that angle, and I had to use tangent function because I had opposite and adjacent. Use the tangent function, and then I subtracted from 90 degrees because this is also 90 degrees. Remember, we talked yesterday that this is a rectangle, so opposite sides are equal to each other. All right. And that's all what we need to do for solving that tangent of the opposite side and the adjacent side, and then we have to do our inverse tangent function to find out the angle and then subtract from 180. If you don't do that and you're trying to find this, and this is 35, then you can say, well, from the angle you're trying to find, you are going to use tangent, because then this will be 1350. And then you're going to say the tangent of 35 over 1350, and then go from there, and now you find this angle. All right, that's it for the quiz. Please pass your practice quizzes forward to the sub. He's going to collect them, and I will give them credit. Good luck, try hard, don't leave anything blank, and I'll see you Friday.